So, what have we learned today? That if you're going to speed, you better have a blinder laser jammer or the police will get you. Seriously though, the radar gun is an integral part of a police officer's ability to enforce speed regulation on today's roads. If you've driven on a road or a freeway this week, chances are you've seen a police officer pointing a radar gun at you. More than likely, he saw you before you saw him. You know, they're either right around that corner or on the side of the road with their entire car hidden in the bushes. I don't know how they do it, but they're clever. And unfortunately, because it takes less than 0.3 of a second for the radar gun to get a reading of your speed, and the average reaction time to visual stimuli for a human being is 1/4 of a second, you have virtually no time to decelerate. And if you're well over the speed limit, you'll be going to sleep that night wondering how much money you're going to have to fork over to Uncle Sam. Unlike your conventional gun, radar guns do not fire physical projectiles. Instead, they produce a radar signal that's emitted from a radio transmitter in a narrow beam. This narrow beam travels towards the target, hits the target, and bounces back into the radar gun's receiver. Considering this beam travels at around 300 million meters per second, the radar gun works in the blink of an eye. Well, we know how the radar gun works on the surface, but how does the radar gun really work, in physics terms? As Connie explained earlier, the radar gun uses the Doppler effect. The Doppler effect is the change in frequency of a wave in relation to an observer who is moving relative to the source of the wave. This shift in frequency, also known as Doppler shift, either stretches or contracts. For example, astronomers use Doppler shift to find the distances and velocities of galaxies relative to us in the universe. When a galaxy is moving away from us, it is what you would call redshifted, meaning as the galaxy moves away from us, the light emitted by the object is stretched out, which causes it to have a longer wavelength or a lower frequency, which is towards the red end of the electromagnetic spectrum. If it's moving towards us, or blue shifted, the wavelengths are shorter and it's closer to the blue end of the spectrum. The radar gun uses this same concept, along with the information it gathers from the moving vehicle, to accurately calculate the vehicle's velocity. The radar gun is not without its limitations though. And if one is knowledgeable of these limitations, it is possible to get out of a speeding ticket. You didn't hear that from me though. Target size, shape, and reflectivity all play a part in capturing an accurate reading from the radar gun, and they all affect the radar gun's detection range. Angles also have an effect on the final reading of the radar gun. Clocking a target at an angle can lead to angle error, which then can result in a speed that is not entirely accurate. Antenna positioning and patrol car positioning can have a negative impact on speed readings. Vehicle interference, when oncoming traffic interferes with the actual target, can in fact result in a higher speed reading as well. Radar guns are an effective way to determine the velocity of a moving vehicle, even though, with anything, there is room for error. Always ask the police officer if he's checked his radar gun that day. If he's tested it, throw in a little cosine error, to throw him off his game a little bit, and he might just let you drive away without a ticket.